Factors and products, lesson 5. Expanding polynomials into the form ax squared plus bx plus c. What is kind of cool about this is the first step before the biggest concept that you need for next year in grade 11 pre-calculus, which is factoring. So we're going to do the opposite first. We're going to expand it out. So this right here, just for future reference, this right here is a factored form of a quadratic. Okay, and a quadratic just means that you have a variable with a squared in it in the function. So I'm going to show you a multitude of ways, and guess what? You can use any way you would like. Ultimately, we would love for you to use the double distributive law, which we will get to here. I'm just going to do something here. FOIL is kind of a cool way to think about it. It's first, outside, inside, last. But I'm going to show you a way that I use rainbows. Okay, so with this one right here, this is kind of what you did in the last lesson, and I'm just going to put my factors up top here. And if we wanted to, we're also going to try out the algebra tiles method. So I have the x plus, should be x minus 4 here, and on this side we have x plus 2. So if we have x times x, this is where we would put the answer to it, x squared. X times negative 4 is negative 4x. And then for this one, I'm going to go x times 2. So x times 2 is 2x. And then 2 times negative 4 is going to be negative 8. So now what we're going to do is we're going to create a statement here. We're going to say that it's x squared. Negative 4x plus 2x is going to be negative 2x minus 8. Okay, so that's how we would use the box multiplication method, and that's something that we have we've been actually doing that since grade, I don't know, 5. This kind of thing, only we would use the whole numbers, so we would say 10 plus 2 or something like that. But it's something that you've been doing for a really long time. If you really like the algebra tiles, this is how I would set up. So first things first, across the top, you can pick either one, it doesn't matter. But you would write your x. Your x plus 2. And on this side, I would have my x block. Oh, sorry, that's minus 4. And all of these guys, because they're negative, I'm just going to do that. Okay. And then x. And then what I have left here is positive 2. So I'll only put red on it if it's negative. Okay. So then this right here turns into an x squared. X times x is going to be your x squared. I'm going to say x times negative 4 is going to be negative 4 x's. So 1, 2, 3, 4. These are all x's. I'm going to also highlight them in red because they're negative. And on this side I have x times 2. So I have 2 bars of x's like that, and they're positive, so I'm going to keep them white. And then I have x times, I have 2 times negative 4, so I'm going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. They're actually all going to be negative. So now what I can do here is I can do the exact same thing here. I have 1 x squared Negative 4x plus 2x is going to be minus 2x. And then I have minus 8. So it's the exact same outcome, just two kind of different methods. So if you like the visual method, awesome. If you prefer the box method, awesome. Ultimately, it's going to be beneficial algebraically for you to know how to do the distributive law. But we're just wrapping our heads around stuff right now. So I'm going to put here, I'm going to have x, and I'm going to have plus 5 over here. I'm going to have x and negative 2 here. X times x is x squared. X times 5 is 5x. X times negative 2 is negative 2x. Negative 2 times 5 is negative 10. And now I'm just going to collect like terms because this and this are my like terms. So I have x squared, 5 minus 2x is going to be plus 3x, and then negative 10. What? Negative 10. So this is the same thing as before. We're going to have our x here, and then I have 1, 2, 3, 4, 5. Okay, and then I have x going down this way for my algebra tiles, and then I have 1, 2, but remember these guys are negative, so I'm going to color them in red. X times x is going to be x squared. I have 5 x's, so I have 5 ones times an x, so now I have 5 x's. All these are my x's. On this one, I have negative 2 x's because I have 1 times x. So I have an x and an x, but we're going to color that in red because it is negative. And I have an array of 2 by 5. Ones 1, 2, 3, 4, 5. For altogether being 10, because there are 2, and they are negative. So if I collect all my like terms here, all my like shapes, I have my x squared, 5x minus 2x is plus 3x, and then I have minus 10, just like that. Okay, so my last one here. We're gonna find the comfort of the box, and if you wanted to also do algebra tiles, if you feel most comfortable with that, make sure you do that method. And I have an x and a negative 7. I have an x and a negative 3. So this becomes x squared. X times negative 7 is negative 7x. X times negative 3 is going to be negative 3x. Negative 3 times negative 7 is going to be positive 21. I'm going to collect my like terms. And I'm going to write my statement. X squared minus 10x plus 21. Okay, so there's that method. So now what we're going to do is we're going to try another method. Some people call it FOIL, but it's using the distributive property. X minus 7, x minus 3. And so the first thing that we're going to do is we're going to take this first, this term here, and I'm going to multiply it by my x, and I'm going to multiply it by my 3, or negative 3 I should say. So when I do that, I get x times x is x squared, x times negative 3 is negative 3x, and now I'm going to go the other way. I'm going to say x times x, and x times, oh sorry, I picked the wrong one. Sorry. We're going to start at negative 7, and we're going to distribute that to the x, and then we're going to take this negative 7 and distribute it to the negative 3. So when I do that, I'm going to say negative 7 times x is minus 7x, Negative 7 times negative 3 is going to be positive 21. So I'm going to collect my like terms, which instead of in two boxes, I just have right side by side each other here. I'm going to say x squared minus a 10x plus 21. So this right here is kind of the ultimate. That's kind of what we're kind of going for here when we're doing algebra. But if you wanted to use the box method or the algebra tiles method, especially in this beginning part, just so that you're getting the hang of it, go for it.